Hello. So this is perhaps the most complicated exercise in factoring that you'll face on this course. And this is factoring a quadratic where the lead term is not just 1x squared, so we can't just use the basic principles that the sum of the factors or the difference of the factors needs to equal the middle term. So I'd like to ask you first of all to pause the video and try to expand these two expressions shown here. I hope that you have done these successfully using whichever method, and what you should find is that the first one is 2x squared minus 8x plus 3x minus 12. In other words, 2x squared minus 5x minus 12. And the second one is a little bit more complicated. 3x times 2x is 6x squared. 3x times minus 9 is minus 27x. The 5 times the 2x is plus 10x. And the 5 times the minus 9 is minus 45. So altogether we have 6x squared minus 17x minus 45. I hope you got those correct. Now if we look at these closely, look at the first one, the term in x, the minus 5x, occurred because we had minus 8x and 3x. And the minus 8 was because we'd multiplied the 2 and the minus 4. And in the second one, the middle term minus 17x has been formed from minus 27x, which was the 3 and the minus 9, and the plus 10x, which was the 2x and the 5. So we're still talking about sums and differences, but rather than just being the factors of the number term, it's actually the factors of the number term and the coefficient of x squared. Suppose we were asked to factor 2x squared plus 13x plus 18. What can we establish straight away? Well, the first thing perhaps is that the number term plus 18 means that both of the terms of the brackets must contain the same sign. Secondly, because the middle term is plus 13x, then that middle term must both be positive. And lastly, if this does factor at all, the only way we're going to get an expression containing 2x squared is by having 2x in one bracket and x in the other bracket. So we need to consider all the possible pairs of factors of 18 as being possible candidates, and they can be in either bracket. So we're going to end up with the possibilities like this, and clearly what's going to happen is that one of these numbers is going to be multiplied by 2. Specifically, this list is going to be multiplied by 2x, and this list is going to be multiplied by 1x. So we're looking for the sum of these two products of factors to be 13. So going through it step by step, if we look at the first list, we're going to multiply the 18 by 2, which will be 36 and 1. That isn't a sum of 13. On to the second one, multiplying the 1 by 2, we'll have 2 and 18. That's not 13. 18 and 2, that's not 13. 4 and 9, that is 13. So the 4 and 9 would add up to 13, and that is exactly what the answer actually is. We're going to have 2x plus 9 multiplied by x plus 2, and then the 13 we need in the middle is going to be got from the 2x times over 2 and the 9 times by the x. Let's have a look at another example. 3x squared plus 7x minus 20. If this does factor, it's going to have to be 3x in one bracket and x in the other. However, because it's a minus 20, the signs need to be different. So we could have a positive in this bracket and a negative in this bracket, or a negative and a positive. Either way, we're looking at a difference of the product pairs as being 7, and we'll figure out exactly which way round the signs go later. So the possible factors of 20 are, of course, 1 and 20, 20 and 1, 2 and 10, 10 and 2, 4 and 5, and 5 and 4. And we're going to multiply one of these lists by 3x and the other list by 1x. We're looking for a difference of those two products of 7. So starting at the top, we're going to have 1 and 60, that's not 7, 20 and 3, that's not 7, 2 and 30, no, 10 and 6, no, 4 and 15, no, and 5 and 12. 5 and 12 will have the difference of 7 that we need, but how do we get 7 from 5 and 12? And of course it's plus 12 minus 5, so it's going to have to be plus 4 and minus 5. So the answer to this is 3x minus 5 multiplied by x plus 4. The 3x will multiply by the 4 to give you the 12x, and the minus 5x will give you the plus 7x, which is the correct answer.